Today we are talking about the cosine law. The cosine law and when to use it. Triangles that don't contain any right angles are called oblique triangles. Okay, this is a good example. When to use the cosine law, the first case is if we know the length of all three sides of the triangle, and we want an angle. That's the first case. The second case is if we know two sides and the contained angle. Sorry about the bad writing on the edge of the screen there. And whenever I say we know two sides and the contained angle, it'd be like if we knew this side, and the contained angle is right in the middle of those two. That is a contained angle. So you must know either side around an angle. And whenever we have that, we want the length of the missing side. So again, just to review, case one, we know the length of all three sides, and we are looking for one of the angles inside, or we can use the cosine law if we know two sides, and that contained angle, again, the angle in between them, and we want the length of a side, which really is the only other side of the triangle. So the cosine law, in review. The cosine law has, if we're looking for a side, is the other two sides added together squared minus 2 times the other length of the other side's cosine of that angle contained between them. Again, if you're looking for a side, you must know the other two sides and the angle between those sides. Or if you're looking for the angle, we use all the different sides. So the sum of the two sides around that angle, and then we take away the other side, the one opposite the angle, and we divide by 2 times the length of each side around the angle. Well, now let's have a look at solving a few. So first I thought we should go through a bit of the math. And here, if we had a squared equal to that, we get a squared equal to 36 plus 81 minus, and if I put all that in my calculator, I get 76.37. Then I get a squared, after I add those two and subtract that, equal to 40.63. Well, the opposite of squaring is square rooting. So to get rid of the squared on the a, I square root both sides. I end up with a, I get that, and in the end, I get a equal to 6.4. Okay, I would recommend you take a minute and try this in your calculator. I tried b, and you should try part b as well, and I end up with b equal to 4.4. Again, I'd pause the video at this point and check to see if you can get both of those answers. Down below, we were solving for an angle. And here, I got 144 plus 100 minus 169 all over 240, which gave me cosine b equal to 0.3125. Excuse me. Now, here's a good little test for you. The cosine of any angle cannot be greater than 1. Always, it should be between 0 and 1. If you get a number bigger than 1, or I guess between -1 and 1, you can have a negative if it's an obtuse angle. But if you have a number bigger than 1 or less than -1, then you have made a mistake and you should go back and check your math. So again, to get the b, we take the inverse cosine. And finally, I get 71.8, which in the end rounds to, because we like our angles always to the nearest degree, to 72 degrees. Again, pause the video, see if you can get this one. In D, I was able to solve angle A to 39. You should check that you were able to do that following the same procedure. Now we move on to an example, and we are asked to find the missing side rounded to the nearest 10. Well, in this case, our missing side is C, this is side B, and this is side A. We see that we have the length of two sides and the angle contained between them. So this is the perfect opportunity to use the cosine law. So I can say C squared equals, so C squared, the side over here, equals the sides on either side of the angle, added together and squared, minus 2 times those sides, cosine of the angle. In our case, the angle is C. C squared equals, and you don't need to write the formula part, you can go straight to the number part if you want, 44 squared plus 52 squared minus 2 times 44 times 52 cosine, and the angle is 38. Take a minute, have a look, see where I got those numbers. You can then try that in your calculator, and I end up getting C equal to 32 centimeters when I do this. I decided not to show the work, as you could try it in your calculator on your own and see if you could get it. Also, it would use a lot of space and possibly just get a bit messy if I had tried to do this on the board. Again, try that in your calculator. Now we move on to finding a missing angle. Well, to find a missing angle and use the cosine law, we need to know the length of all three sides. And we do in this triangle. So it's the perfect other case to use the cosine law. So in this case, I am looking for angle C. So I go cosine C equals, I add the two sides that are around my angle, I square them. So in this case, we have side A, side B, and side C. So I would go A squared plus B squared minus C squared, all over 2AB. You could check the formula earlier in the note and see that. Then I get cosine C equal to 76 squared plus 46 squared minus 38 squared, all over 2. And a good rule of thumb is that your first two numbers in this fraction should be the ones on the bottom. Then I plug those into my calculator, and I get cos equal to 0.9222. You can check that in yours. Again, the number is between -1 and 1, so I know that I can use cosine for it. I take the inverse cosine, and I, in the end, solve my angle to be, rounding to the nearest whole number, 23 degrees. Again, I would recommend that you work your way through this example and see if you can arrive at the same answer I did. Excuse me. The final example in the note has us drawing a triangle and then solving the whole thing. So I quickly draw a triangle. I'm told it's A, B, C. And I know the length of side A is 12. This is A. The length of side B is 15 centimeters. And angle C is 46 degrees. Perfect opportunity to use the cosine law because I know two sides and the angle contained between them. Side C would be there. So I need to find angle A, angle angle B and side C. I'm going to find side C first just because I know the angle across from it and the two sides. So I set up C squared equals A squared plus B squared minus 2AB cosine C. And I get C squared equals 12 squared plus 15 squared minus 2 times 12 times 15 cosine, and the angle is 46. I plug that all through my calculator. I get C squared equal to 118.9. I remember to take the square root of both sides to get rid of that squared. And I get 10.9, which I will round to 11 centimeters. So now I have solved for side C. I've got one of my three things done. Next, I'm going to solve for angle B. So for angle B, I would say cosine of angle B. And then I would use the other two sides. So I'm using B here. I'm going to use A and C. So A squared plus C squared minus B squared all over 2AC. So I get cosine angle B equal to 12 squared plus 11 squared minus 15 squared all over 2 times 12 times 11. And I end up getting cosine B equal to 0.1515. And when I get that 0.1515, I know that I'm between -1 and 1, so I know that cosine will work. I take the inverse cosine of that, and I get 81. And again, I recommend you try these in your calculator. And finally, I need to solve for angle A. Well, we know the sum of all angles in a triangle is 180. So if I take angle A and I take away angle B and I take away angle C, I can solve for angle A. I could have used the cosine law. At this point, I really could have used the sine law as well, but it's easier to do this, so I choose to do this, and I have solved that example. This brings us to the end of our note. So you may try some of the cosine work that I have for you, and if you have any questions, please do not hesitate to ask. Good luck.